All right, so let's continue dealing with our matrix operations and let's define how we can multiply two matrices. So let's consider matrix A, which is M by N matrix. So A has M rows and N columns, and B is an N times P matrix. So B has N rows and P columns. So notice here, the number of columns of the first matrix is equal to the number of rows of the second matrix. Then we define the product of matrix A times matrix B as applying matrix A to each of the columns of matrix B. So the first column of this product would be what I get when I multiply matrix A by the first column of matrix B. The second column of the product would be what I get when I take matrix A and multiply this by the second column of matrix B. So the way that we have defined matrix multiplication falls back on our earlier definition of the way we defined a matrix times a column vector. So we're just going to do this product for every single column that we have in matrix B. Okay, so let's take a look at an example. So for example, let's say we have matrix A, which is for top row is -1, 0, 3. Second row is 2, -2, 1. So matrix A we have is a 2 by 3 matrix. Matrix B has 3 rows and 4 columns. So that is a 3 by 4 matrix. And here we see that matrix A has 3 columns, and that's the same as the number of rows that matrix B has. And we'll see why that's important. So the way this definition of matrix product goes is we're going to take matrix A times the first column of matrix B. So we have 4 separate matrix vector products we need to calculate. So I would take this 2, 6, 1 times matrix A, and this would give me -1 times 2 plus 0 times 6 plus 3 times 1. That's where this -1 comes from over here. And to get the second entry, I would take the second row times the entries of this column vector. So this would give me -2 times 2, 2 times 2 plus -2 times 6 plus 1 times 1. And you can verify that that gives us -7. Then we come over and apply matrix A now to the second column vector of matrix B. And you can check the arithmetic there. So after I do each of these products, what I'm left with is a column vector of 2 entries, because this first matrix A had 2 rows. So this is going to give me the first column in the product. This 5, 4 is going to give me the second column in the product. And then we continue with the others. Whoops, I missed one over here. So first, we would take the third column of B and matrix A, and that gives us 3, 3. And then I would take this fourth column of matrix B, multiply A times that fourth column, and this is going to give me the last column in the product. So then altogether, our product AB, we can write out as the first column is 1 minus 7, the second column is 5, 4, the third column is 3, 3, and the last column is -2, 15. So that's how we can calculate product of 2 matrices. It is quite a bit of arithmetic that we need to do. So on the next slide, we'll talk about how we can do this in Python as well. And before plugging this in to Python and checking our work, let's just comment on a couple of really important observations here. And that is, we can't multiply any 2 matrices that we can imagine. The size of these matrices are important. And in fact, they don't need to be the same size. What we require is that this product is going to be defined when we have the number of columns in matrix A are equal to the number of rows in matrix B. So we need the second dimension of matrix A to equal the first dimension of matrix B. And so when that happens, this product is defined. When these matrices don't satisfy that condition, then the product is undefined. We can't even discuss the product. And at the end of the day, the result that we wind up with is going to have potentially a different size than both of the matrices that we started with. So in the end, we're going to wind up with a matrix AB. That product is going to have M rows. So it's going to have the same number of rows as matrix A, and it's going to have the same number of columns as matrix B. And so let's take a look at how we could code this in Python. So I have a screenshot here from Google Colab, and then we'll actually go into a Colab document and we can experiment a little bit. Right, we're gonna wanna work with arrays. So we're gonna use the NumPy library that I'm gonna abbreviate with MP. So here is the matrix A from the previous slide, the previous example that we looked at, the 2x3 matrix. Here was the matrix B. And now we're going to take the product of these two matrices. And I'm going to use MP because that's how I abbreviated NumPy. So I'm going to use the NumPy library, and the function I want to call in is the dot function. So dot means take the product of A and B. I've assigned this to C, and then we can print the output to C and check that we get the same result that we got on the previous slide. So I will go into Python in a second. But what I want to emphasize here is you definitely do not just want to put a regular old multiplication here. Python's going to read this as regular multiplication, and we'll see how it tries to fit that idea when the objects it's multiplying are matrices. We want a very special type of multiplication, matrix multiplication. So we need to indicate that type of multiplication using the NumPy library, so np dot. And here we'll see that the order is important when we're multiplying matrices. So it's important that you first enter A and then enter B if you're calculating A times B. Okay, so now I am working with an interactive Python notebook in Google Colab. I haven't given this a name just yet, but I will put a link to whatever I call this in the information about this video. So you can click to the link and play around with this in your Google Drive if you like. So first I've got the code that we used when we were dealing with addition and multiplication by a scalar over here. So I import the NumPy library. I define that matrix A and B from that earlier example, and then we used this np add function to add those two together. And if you want, you can verify to yourself that these commands below will give me the same output as command C. Now let's take a look at the matrix product that we were working with in this problem. So I don't need to import the NumPy library again because I've done that in my previous block of code. I do want to introduce two new matrices, A and B. And these are the matrices from the example in the slide. So that's matrix A, I've entered. Matrix B, I've entered using np array. And down here, we take the product. I'm going to call this matrix C, and I do np dot AB, and then I print that output to the screen. I'll run that here. And here we can check that this is the same exact answer we got when we did the arithmetic by hand. And again, I would highly encourage you not to do everything in Python while you're really getting familiar and learning how to do matrix multiplication. It really helps getting your hands dirty a little bit and doing the calculations. And I would use Python as a way of checking your work for the time being until you're becoming a matrix multiplying machine. But this works out. And so we can play around with a couple of different ideas while I've got this Python notebook open. So first of all, if I were to flip the order of multiplying things, let's see what happens. I get an error down below. And that's good. So here we can see that there is some dependence on the order that we multiply matrices. Matrix multiplication will verify is not a commutative. So A times B is not going to be the same as matrix B times A. And in fact, it is likely that it's not defined. The product is not defined both ways. So I want to be sure that I specify my matrices in the order that I see them in the product. So that's great. So here's a note that says, okay, we shouldn't do things this way. Well, let's see what happens if I disregard that note. So let me define some matrix D that I'm just going to try and say is A times D like this. And let's see what happens if I try and print that output to the screen. Here I am getting an error, right? So doing it using NP dot got the output that I expected. Oh yeah, this gave me an error because I have a D over here. I should have a B over here. So if I want to define this product using the multiplication symbol here, let's try that again. I am getting an error when I try and multiply A times B just using this multiplication symbol. Python is telling me this product doesn't exist. We know it exists. We've already calculated it by hand. And then we calculated it the proper way using Python with the np dot function. And we can check that we got the right output. This is not giving me the right output because I had a D there. This was the right output, right? So we want to be sure we're using this np dot. And if you're curious about, well, what is this symbol down here doing? What operation is going on here? Okay, so now I've got another block of code down below where I want to just illustrate the difference between what np dot does, which is the right matrix multiplication, and what the A asterisk B does, which is the wrong type of matrix multiplication. So here I've got matrix A, which is the same 2x3 matrix that we had in the previous example. And now, instead of using this matrix B where the product was defined, let me come up with a matrix B down here that has the same size as matrix A. So both of these matrices are 2x3. And so recall, if I want to take the matrix product of this matrix A and this matrix B, it should not be defined because I have 3 columns in matrix A and only 2 rows in matrix B. And these numbers should be the same in order for this product to be defined. So if I were to run this block of code, I should expect to get an error, which I do. When I run separate command, if I define B, the D as the product of A times B, just using the regular old multiplication symbol, and then I print this output to the screen, this is telling me that this product exists, and it definitely shouldn't. And if you look at our matrices, so let me print matrix A, and then put a line break. I'm going to print matrix B, and then a line break. And then I'm going to print matrix D, which is the product. You can see that, well, maybe I'll put in another line break here to make it a little more readable. That it's taking this matrix A and this matrix B and multiplying component wise. So it's taking A11 times B11, and that's how it's defining the 1, entry in the product. And then it's taking 0 times 3, and that gives me 0. And then it's taking 3 times 2, and that gives me 6. This is not at all the way matrix multiplication works. So do not multiply matrices in this way. Be sure that you use the np dot command to multiply matrices. It works out with addition, meaning with addition, we were okay using np add or using the regular notation, because when we add matrices, that's exactly what we do. We add component-wise, entry-wise. That's not how multiplication works. So we want to be careful that when we do this in Python, doing matrix multiplication, we use np dot. Okay, so that's a wrap on using Python to do some matrix multiplication. As I'm doing the examples in the rest of the videos for this section, I would encourage you to do them on paper, do the arithmetic yourself, and use Python as a way of checking your work.